The following past paper question states that which expression gives the standard enthalpy change of combustion of methane. Now, the first thing I'm going to do is I'm going to figure out what is meant by the standard enthalpy change of combustion of methane. So it's the reaction in which 1 mole of methane burns in excess oxygen. So it reacts with O2 and ends up producing carbon dioxide and H2O. So and I need to balance this equation. Methane should be 1 mole, because in enthalpy change of combustion of methane should be 1 mole. 1 mole of methane burns in excess oxygen. So if I balance this should be 2H2O, this would be 2O2. Methane is a gas, write down the states as well. Oxygen is a gas. CO2 is a gas as well. And H2O is going to be a liquid in standard conditions, because he's using the term standard enthalpy change. So H2O is going to be a liquid. Now this equation represents the enthalpy of combustion of standard enthalpy change of combustion of methane, which is CH4. So this reaction represents that. Now which expression gives the standard enthalpy change of combustion of methane? So this is your reaction. Now there are two ways of figuring out the enthalpy change of a particular reaction. One is that if you know the enthalpy of formation of all the reactants, you know the enthalpy of formation of O2 as well, you know the enthalpy of formation of CO2 as well, and you know the enthalpy of formation of H2O as well. So one way of figuring out the enthalpy change of this reaction, or which is enthalpy change of combustion of methane, is that if you know the enthalpy change of formation of all your reactants and the enthalpy change of formation of all your products, what you simply need to do is that the enthalpy of that particular reaction, which in this case is the enthalpy change of combustion of methane, CH4, it's going to be equal to the enthalpy change of formation of products, which I'm writing with a P. You're going to sum them up and minus subtract the enthalpy change of formation of your reactants. And now we're going to look at this reaction. My products in this case, in this reaction, are CO2 and H2O. So I'm going to apply this formula. The enthalpy change of combustion of methane would be equal to the enthalpy change of formation of my products, which in this case, one is CO2 and the other one is H2O. So that would be multiplied by 2, because I have, in my equation, I have 2 moles of H2O. So it would be 2 times the enthalpy of formation of H2O. So these are my products, and what I'm going to do is I'm going to subtract it from my reactants. I'm going to minus my reactants, the enthalpy of formation of my reactants, which in this case are O2. And O2, remember, the enthalpy of formation of O2 elements is 0, because you don't need to form elements. Elements are already in their formed state, so you don't need to form them. So the enthalpy of formation of elements like oxygen would be 0. So it's going to be the enthalpy of formation of CH4, which is my reactant, and the enthalpy of formation of O2, which I already told you is 0. So this would be the expression. If I know the enthalpy of formation of all my reactants and all my products, then the enthalpy of this particular reaction would be the enthalpy of formation of products minus the enthalpy of formation of reactants. Now, if you look carefully, this expression that you're getting is, according to this expression, option C is going to be, you're getting exactly the same expression in option D. So option D is going to be your, it's going to be your correct option for this particular question.